as you were getting through and you started working, you got to number 4. You got to the point where you saw that you had 1/2 equal the secant of theta, which meant I made the hint yesterday. It's much easier to work with the reciprocal properties as opposed to the inverse properties. So if you reciprocal 1/2 and you reciprocal secant, you get the 2 equals the cosine of theta. Well, will I ever get a cosine of anything equaling 2? No. So your answer was no solution.
I just want to make sure you come out with
Absolutely.
because if you put 2 over 1, the cosine would be hypotenuse of 1.
Remember, guys, remember what's happening in this problem is you got to the point where you had 1/2 equal the secant of theta. You always want to try to solve your equations in terms of the standard reciprocal or standard trig functions, cosine, sine, tangent. So if you reciprocal it, you have to reciprocal both parts. I haven't got there yet. On 5, you have 5 equals 3 minus the cosecant of theta, which means you subtract 2, divide by -1, and then again, at this point, solve it in terms of a regular trig. The reciprocal of cosecant is sine. So I'm going to write this as sine of theta is -1/2, which means one angle has a sine of -1/2. Well, sine is negative in which 2 quadrants? Sine is negative in 3 and 4. So sine, opposite hypotenuse, which means my opposite is the -1. That gives me a 30 degree. 30 degrees down is pi over 6 down. When I go past a full pi down to 6, I'm now at 7 pi over 6. If I go to the second quadrant, or I'm sorry, the fourth quadrant, if I go down 6th from 12th to 6th, if you will, I'll be at 11 pi over 6. That's what I get. Okay. All right, 6, cotangents. 4 equals 4 plus 2 cotangent theta. Subtract 4, you get 0. Divide by 2, you get 0. Okay. Right now I have cotangent then of theta is 0. If it's 0 over 2, that's fine, because what's 0 divided by 2? 0. And you're okay if you left it like that. Leave it like that. Watch what happens. Because now, cotangent is the reciprocal property of what? Tangent. If I flip cotangent to get tangent theta, what's the inverse of 0? Whoa, say it! Undefined! Which means if I have 0 over 2, it's now 2 over 0. That means it's your y over x, where x is 0. So now you're at a quadrantal. Where is tangent undefined? Tangent, remember when we found tangent before, you're looking at values of x that are equal to 0. It's equal to 0 at pi over 2, and and 3 pi over 2. What is? Tangent is undefined at pi over 2 and 3 pi over 2. Because tangent is y over x. So basically that means you're looking for where is x equal to 0. Because if x is in the denominator, you have an undefined value. That's where that came from. Even if it was 2, it didn't matter. You're still looking at, in order for it to become undefined, you'd have to have a 0 for x. Those are your answers. Tangent, it's basically, one second. It's basically, what you're asking is this. what angle has a tangent value that's undefined? And when you have an undefined angle value, that means you had to divide by 0. Where on our circle is 0 in a denominator? 0 is only in a denominator here because I do y over x for tangent. That's why it's at pi over 2, pi over 2. What do you? Oh, I didn't hear. What was that? Oh, about the circle here? Hold. Yep, that's fine. Yep, that's perfectly fine. And when you're dealing with cotangents, it's pretty, especially when you're on quadrantal, it's not a big deal. But when you start getting like cotangents and you've got the root 2's and all that all thrown in there, I mean, you know it's going to be a 45 to see a root 2, but you got to make sure you place in the right spot. So that's why I always fall back on, I could go to the reciprocal and just be a little bit quicker. But by all means, if you remember x over y, no big deal. I'm absolutely fine with that. Okay. Those were the first 3. Aside from that one, what was the next one? What was it? 10? Okay. You've done this problem 100 times in your lives, at least. This is the exact same problem as this. What do you do first? Add 7x. You pick on the little guy, don't you? You do the exact same thing. It just so happens to have more letters. Okay. So I pick on the little guy, which means I'm going to add 7 cosecant theta to the other side. So I get 6 cosecant theta equals -3. Divide by 6, cosecant theta -1/2, which means sine theta -2, which means no. Which means no. We had to do what, 11 after that? Okay. 11, same idea. Same basic idea when you're talking about 11. When we do walk through 11, you've got 1 minus 2 secant theta, -2 plus secant theta. I need to pick on the little guy, which means I'm going to add 2 secant to the right. At the same time, I'm going to add 2 to the other side. So I'm going to get 3 equals 3 secant theta. Which means I'm looking for a theta, a secant value. I'm searching for a secant. I'm just making up somewhere. What's the inverse function, or excuse me, what is the reciprocal function of secant? Cosine. What's the reciprocal of 1? What angle has a cosine of 1? Almost. You went the wrong way. Getting there. Warmer. Warmer. Colder. Yeah! Answer is 0. What's that? This is asking you what angle has a cosine value of 1. Cosine is your x-coordinate. The only place on the circle the x-coordinate is 1 is that circle. Okay. Page 3 was 11 again, right? What do? You add cosine, right? Now this looks like the problem we did in class yesterday. What do they have in common? Factor it out. Do I now have two terms that are set equal to 0? Set them both equal to 0. And there it's, what angle has a cosine of 0? What angle has a cosine of negative 1/2? Okay. And then go through the circle to figure that out. I wanted to make sure I had time to finish off the fun one on the back. What was the other one on that side? That was
Wait, on the back?
on the third page. On the third page. Well, 15. Was it 15 and 16 or just 15? Just 15. Are those okay? Yeah, I just want to make sure I have time to do that one on the back. Do I need to finish these before I go too far? Are you guys okay when you get here? Yeah. Did you add 1 divided by negative 2? I'm sorry, subtract 1 divided by negative 2. So you have, so right now you should have sine squared x equals 1/2.
Okay, yeah.
And then you square root it.
Okay.
Don't forget plus minus.
Okay, yeah.
So 16, you've got 4 cosine squared x is 1, which means all you have to do is divide by 4. And like I was just telling Maggie here, whenever you take a square root, you have to do plus minus on the other side. A lot of times you guys will forget that. So you're going to get cosine of x equals plus or minus 1/2. So what angle has a cosine value of plus or minus 1/2? That means you're going to have 4 solutions because you're looking for cosine to be positive and negative. It winds up being, that happens in every one of the quadrants. Cosine for 1/2 means that you're opposite to 30, you're opposite of root 3, so it's a 60-degree angle. So this is all of your pi over 3s. And la piste de resistance. Bonjour. So you guys, when you do that, you didn't even see it. You guys put your mustache. You guys go to me, your French me. Hello, bonjour. Gotta get some perfume, man. Gotta get the baguette for lunch. Oui. Okay. So, a lot of times in math, we like to make stuff up. And I'm sure you've noticed that because we have imaginary numbers. We're like, I don't know how to do this. Let's make an imaginary number and we can do stuff. Well, that's kind of what happens a little bit here. When you see something that looks like crap, but some of that crap looks kind of the same in the problem, we do this little trick, and math people are weird that they came up with this. They said, hey, hey Euclid, I got this great idea. See what I did there? Euclid was a math person.
No one's
Just not inspired. We're going to do this. We let u equal cotangent of x. What this is called u substitution. You use u substitution whenever you have something that looks awful, but yet you can rewrite it in easier terms. Bless you. So what we do here is we use this thing called u substitution. So now I get 2 u to the 4th minus u squared minus 15 is 0. And now you're at a simpler-ish quadratic, 4th degree, 2nd degree constant, so I can factor it just like I would anything else. What times what is negative 30 that I add together to get negative 1? Negative 6 and 5. Very good. So you have 2u to the fourth minus 6u squared plus 5u squared minus 15 is 0. And now I'm back to a factor via grouping style problem. This setup is very similar to things we did. We did this with I believe. So it's kind of the same thing. You'll see this. I'm pretty sure this is the last time we actually ever use it in Algebra 2. You'll see this a few times in this unit over the next week or so. And then you'll see it once or twice again in pre-calc, and then you'll see it again in calculus. They use it a lot in calculus, actually. This whole idea, what's called U substitution. What's your GCF then for 2u to the fourth and 6u squared? Take out a 5. Are the two things that are in parentheses the same thing? Woo-hoo! So that means we have u squared minus 3, 2u squared plus 5. So I have now u squared minus 3 is 0, 2u squared plus 5 is 0. That's weird. What did U stand for again? Cotangent. So then I just rewrite. Cotangent x squared x minus 3 is 0, and 2 cotangent squared x plus 5 is 0. I don't know what happened to all my parts here. Okay. And now I solve those independently. Add 3. What is the reciprocal property of cotangent? Tangent, okay. So I'm just going to flip it down, say tangent squared 1/3. Now, how do you undo it? Square root. So I take the square root, and I'm going to get, move this up again, I'm going to get x will equal what angle has a tangent value of plus or minus 1/√3. I don't bother rationalizing this because when I'm searching for the angle, it's easier to do it without. Okay. So when you have an opposite of 1 and adjacent of √3, that's your 30. And this is being plus or minus, that means I'm looking for the pi over 6 in all 4 quadrants. So we'll have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And then do the same thing with the other part. The other part, you'd have to subtract 5 and divide by 2. Can I take the square root of a negative? So am I going to have negative trig functions? Or better yet, am I going to have imaginary trig functions? Right? It's like the look on his face was seriously like total dismay. Please, dear God, no. Not this year. Remember how we did standard form of an imaginary number, a plus bi, a plus or minus bi, things like that? Well, there's a trig form of that as well. It's going to be awesome. It's a formula. It's a formula. Okay. So that's what happens here. The other part you have no. So Colby, like you were saying, you're not sure how to do it. You've done that problem how many times? You've done that one a lot. What's that? It's usually not negative. It's just it's the trigonometric form of an imaginary number. It's a straight formula. It's not. I'm not lying. It looks like it's really, really hard. It's a formula. It's pre-calc. Okay. Also, the other thing you'll learn in pre-calc is this is pretty cool. What's the cube root of 8? It's 2. So you guys know that there's an answer to this. The answer is 2. What if I told you that there's actually 2 other answers? Negative 2 times negative 2 times negative 2 would be negative 8. There's a lot of imaginary stuff. So here's what we got. You did all the ones in blue yesterday. On the first 2 pages, do these for tomorrow. Those 6. Tomorrow we will talk about what's called general solutions, and we will use the examples that we get from for tonight's homework as our examples for turning them into general solutions.